Today we're going to be talking about molar mass calculations. So we're going to talk about what is molar mass, when do we use molar mass, and how we're going to calculate molar mass. Okay, so the relative atomic mass scale makes it possible to know how many atoms of an element are present in a sample of the element with a measurable mass. Now there are two very important concepts that provide the base for relating masses in grams to number of atoms. Now the first important concept is the idea of a mole. Now a mole is the amount of substance that contains as many particles as there are atoms. So it's another unit just to kind of, if we want to figure out how many atoms are in a tissue box, we can say it's 1 mole worth because that's the number of particles or atoms are in that substance or in that tissue box. Now we abbreviate moles as MOL, so you could just drop the E and just write MOL whenever you're doing math or whatnot. And our second most important concept is molar mass. Now, molar mass is the sum of 1 mole of a pure substance. And the molar mass is really the sum of all of the element's atomic masses. So you're going to have a compound, and that compound has many different elements. So you're going to take the sum of all of those elements' atomic masses. So add them all together, and that is the molar mass. Now, we abbreviate the word molar mass to capital M, capital M. So whenever you see capital M, you know that's molar mass. And molar mass has the unit of G/mole. That's grams per mole. So grams on top, mole on the bottom.
Alrighty, so let's go ahead and do some of these practice problems. We're only going to do probably 3 of these, so not all of them. The rest of them will be posted on the Google Classroom for you to go through on your own, okay? So first one we're going to be doing is that K3PO4. Let me see if I can zoom in. Not sure why it's blurry. Let's see if I can focus it. There we go. Okay, K3PO4. What we are going to be doing is we're going to be taking the sum of the atomic masses. So we're going to have to find the atomic mass in the periodic table of one element. So if you look on our compound K3PO4, our first element we have is K, which we know is potassium. Okay, so the first thing we got to do is we got to go ahead and find potassium on your periodic table. And we know, I know I can't really get this super close, but you guys should have the periodic table up and ready to go. When you find potassium number 19, remember on Friday where we said the very last number, the very end number is your atomic mass. So the potassium's atomic mass is 39.098. So we're going to go ahead and write that atomic mass. So we have 39.098. Okay. And then we have to multiply that atomic mass by how many we have in the compound. So you see this number 3 right after the K? This 3 tells me we have 3 potassiums. So we're going to multiply this number by 3. And we're going to close that in parentheses. So that's all going to be about potassium. Any questions so far? So now we're going to go ahead and move on to our next element. But again, we're taking the sum of the atomic masses. So we're going to add. And we're going to continue on to our next element. If you look on your example, our next one is P, which is phosphorus. Let's go ahead and underline that so we know that's our next one. I don't know if turning on this light will help out. Let's see. Okay. Now we're going to have to find the atomic mass of phosphorus on your periodic table. So when you pull out your periodic table, phosphorus is number 15, P. This very last number here, which is 30.974. I know it's a little bit blurry. I apologize. There's no way. I was trying to, maybe if I click, yeah, 30.974. That's your atomic mass of phosphorus. Let's go ahead and write that out. And then we have to multiply 30.974 times how many there is. Well, you see how there's no number after phosphorus? We're just going to assume that's 1. That means we have phosphorus, so we're going to multiply this number by 1 and close that in parentheses. Okay. And then we're going to do it again for our next element. With this time we have oxygen. And again, we're going to be adding. So we have to find the atomic mass of oxygen. So going back to your periodic table, oxygen's right here. And that atomic mass is 15.999. So let's go ahead and write that. And we have 4 oxygens because that number 4 after the oxygen. So that means we have 4 oxygens. So we're going to multiply this by 4. And that is it. So you're going to plug all of that into your calculator. So go ahead and practice plugging that into your calculator. I'm going to plug it into mine as well. So we're going to be taking parentheses, our 39.098 times 3, close parentheses, plus our 30.974 times 1, plus open parentheses, 15.999 times 4. And when you enter, you get all of that. You're going to write the whole number out. So we have 212.264. And if you just remember what we just talked about with molar mass, the unit for molar mass is grams/moles. And that is the most. I'm going to go ahead and do that one. So again, we're going to do one element at a time. So our first, you see how we have a capital and a lowercase? When you have a capital and lowercase, that's going to be one element. But if you remember back up here, we had a capital P and a capital O. That's mean they're 2 different elements. So if you have a capital and lowercase, that's going to be one element. So our element is Fe right now that we have. So if we look on the periodic table, Fe is number 26, and that is 55.845. So let's go ahead and write that. Oh, I wrote that in the wrong area. Whoopsies. Now we have 2 irons. This is Fe's iron. You see how we have a number 2 out in front of Fe? That implies that we have 2 Fe's, so we're going to multiply this number by 2. We're going to close that parentheses, and we'll continue on to our next element. So our next element that we have is, you see how we have 2 capital letters? That means we have 2 different elements. So our first one we have is S. And if we look at S, our atomic mass is 32.066. So we're going to write that out. But how many sulfurs, this S is sulfur, how many sulfurs do we have? Well, do you see this number outside of the parentheses? And think about math. When you have a number outside of parentheses, we have to distribute, right? That means we have to distribute this 3 to both of the elements. So we're going to multiply 3 by how many we have in the parentheses. So right now, you see how we have no number in front of S? So it's going to be 1. We're going to take 3 times 1. So we have a total of 3 sulfurs then. Do we have any questions on that distributing? All right, so let's go ahead and move on to our last part of the compound. And our last element we have is O, which we know is oxygen. So we have to go ahead and find oxygen on our periodic table, which is our 15.999. So we're going to write that out. We have to multiply how many there is. We have 4 inside the parentheses, but we have to distribute the 3. So 4 times 3, well, we have 12 oxygens then. And then you can go ahead and plug it into your calculator. So we will do parentheses are 55.845 times 2, close parentheses, plus, then parentheses again, 32.066 times 3, close parentheses, plus open parentheses, 15.999 times 12, close parentheses. And you're going to get this as your answer. So let's go ahead and write that out. And remember, the unit for grams per mole is like this. Okay, the unit is grams per mole. Alrighty, so let's go ahead and do the molar mass calculations for MgOH2. Now, first thing we got to do is we're just going to find the atomic mass for each of those, and we're just going to take the sum of all of them. So our first element we have is, let me see if I can get this brighter, is magnesium. And if we look on our periodic table, magnesium has an atomic mass of 24.305. So we're going to write that. And then we got to figure out how many magnesiums we have. Well, there is no number after magnesium, so we're going to assume it's 1. So that means we have 1 magnesium, so we're going to multiply this number by 1. Okay. And again, it's the sum, so we're going to have to add. And we'll move on to our next element. Now, the next element we have is oxygen. And if we look on the periodic table, oxygen's atomic mass is 15.999. And now we have no number in front of oxygen, so it's 1. But you see this number outside the parentheses? We got to distribute that to both elements in these parentheses, like we would distribute if we were in math class. So that means we're going to take the 1 times 2. That means we have a total of 2 oxygens. So we're going to multiply this by 2. Then we got to add again. And our next element we have is hydrogen. And looking on the periodic table, hydrogen has an atomic mass of 1.008. And there's no number in front of hydrogen, so it's 1. But again, we got to distribute that 2. So that means we have 2 times 1. That means we have 2 hydrogens. So you're just going to go ahead and plug that into the calculator. So let's go ahead and do that. So we're going to take our parentheses 24.305 times 1, close parentheses, plus open parentheses 15.999 times 2, close parentheses, plus open parentheses 1.008 times 2, close parentheses. And that is our answer. So we're going to write 58.319. And again, the unit for molar mass is grams per.
All right, so go ahead and practice solving the molar mass for these two compounds. Go ahead and pause the video, work it out, and when you get the answers, you can play back. And the work and the answers are these. And that's it.